So for 7-3, we have compound events. There are 3 vocabulary words. Go ahead and copy those down. Pause the video and then continue once you've copied down. So we're going to find a sample space. So you randomly choose a soup and a sandwich, find the sample space, how many combinations are possible. So we're going to create what's called a tree diagram. So a tree diagram always starts with one point and then expands from there. So we're going to split this. So there are 2 possibilities for soups. And then after that, we have different possibilities for sandwiches. So if we look over here, we have 3 possibilities for sandwiches, so we're going to expand from there. So if we choose chicken noodle, we could get a ham sandwich, we could get a turkey sandwich, and we can get a meatball sandwich. Or if we get tomato soup, we could get a ham sandwich, we can get a turkey sandwich, or we can get a meatball sandwich. So if we count all those up, there are 6 combinations that we could get. So that's one way to find sample space. So 6 combinations is our sample space. Another way we can talk about this is to find the total number of possible outcomes. So we're going to do this by doing example 1, find the total number of possible outcomes of flipping a coin and rolling a die. So method 1, we're going to make a table to find our sample space. We could use a tree diagram, just like we used before, but this would just be a different type of a method. So we could get heads 1, heads 2, heads 3, heads 4, heads 5, heads 6, tails 1, tails 2, tails 3, tails 4, tails 5, and tails 6. So that would give us a total of 12 possible combinations. Now, we could always list them out, but there's a faster way, right? Method 2 is to use the fundamental counting principle. So what we're going to do is take each event and we're going to figure out how many outcomes for that particular event, and then we're going to use the fundamental counting principle. So event 1, how many choices do you have after you flip a coin? There are 2 possible outcomes. And event 2, how many do you have after rolling a number cube? There are 6 possible outcomes. So the fundamental counting principle says we multiply those possible outcomes. So we're going to do 2 times 6, and that means there are 12 possible outcomes. So I want you to try to do this on your own. You're going to use the fundamental counting principle to find out how many different outfits you can make from the pants, shirts, and hats listed below. Go ahead and pause the video, try it on your own. Okay, if you pause the video, you should have gotten there's 2 pairs of pants, there are 3 shirts, and there are 3 different types of hats. So therefore, we're going to do 2 times 3 times 3. 2 times 3 is 6, times 3 is 18, so there are 18 possible outfits. Lastly, we're going to talk about compound events. So here, we're not just talking about possible outcomes, we're talking about the actual probability of flipping heads and rolling a number less than 3. So we need to find the probability of each event and then go ahead and multiply. So event 1, what's the probability we're going to get heads? Well, there's only 2 choices, heads or tails. So the probability we're going to get heads is 1 out of 2, right? Event 2, right? We're looking at event 2 now, and it says what's the probability of getting a number less than 3? So the numbers that are less than 3 would be 1 and 2. So that's 2 possibilities out of 6 when you're rolling the number cube or the die. So now what we're going to do is we're going to multiply those 2 things. So we're going to do 1/2. Again, it's the fundamental counting principle, basically, but we're actually going to multiply the probabilities. So 1/2 times 2/6, which gives you 2/12. We simplify, divide by 2, divide by 2, and we're going to get 1/6. So the probability of flipping heads and rolling a number less than 3 is 1/6. You could also list that as a decimal. You could list it as a percent. So if I do the division to get this into a decimal, 1 divided by 6 is going to be 0.16 repeating, and then 0.16 repeating with the 6 repeating times 100 is going to give us basically 16.6 repeating percent, which is approximately, those are bad approximates, but 17%. Hope it helps.